Hi, it's Nate S here, and what I made here, made this all by myself. 0 to 99, that's what it counts. And it turns on it's actually light activated. Turns on at night, right at the dark. And then I got here's my power supply area up here. Plug in this way or this way. So my positives is in the middle pin. These are not connected. And here's the ground over here. Technically it's this one, but this one right here has ground on both sides, so it's reversible. And then I put my negative diodes so it could only go one direction, so it doesn't damage anything. And then here's my static voltage suppressor diode, just to protect it from damage from static. It just helps protect it. Got my voltage regulator. This is the variable, the LM317. So I built it where it's only at 5 volts. And these resistors, part of it. And then what I have here is my light switch. When it gets dark, this is a 7411N, which is pretty much a NOT gate. So I use it for buffing it. And then it goes, this right here is a MOSFET. It's a negative input MOSFET. Or could I say a positive channel MOSFET. So when it's negative, it switches it on, and then it has very low voltage drop when it's on. That's why I like to use a MOSFET for my main power, so it shuts off the whole thing, efficiency. And then here's my smoothing capacitors. Smooth it right here, this big guy. And then it goes over here, it counts with the impulses of 555. That's where it starts impulsing. Sorry, not counting, but impulses to the counter. And that's capacitor does that too. And then it starts counting on these chips in binary code. It's a 74161. And here's the outputs. They basically both count from each other, so it counts this one first, and then it counts this one later on. So it counts to this one, and I make it where every time it has 10 in binary code, it resets itself, and then it starts, that's when it counts to this one. And then here's the decoders chips. Here's a NAND gate. I just use that for when it resets. Like when it goes to 10, it uses those two inputs to reset it. And then here, these two right here are basically decoders. They decode it basically from binary code to 7-segment display code on both of them to these digits. But these are actually a common inode, so they don't really, they don't, well, it reverses it so it doesn't use, it's kind of the wrong one. So basically it's common inode, So it turns in, it's supposed to work on a common cathode with these guys. And these switches, these make it negative, and then I put a chip underneath, which is pretty much a NOT gate chip, so it inverts it. And then I use this for basically just a line. They call it it's just a resistor network. So one side is just common for all these little resistors that go out to each pin individually, and basically that kind of connection, and then it goes to each of these segments. And then right here, actually I used a little bit of, it uses quite a bit of resistance, so I use these as a resistor on one digit, except for one, because there's 6, it says 7, so that means it's less than 1 digit. And then 1 digit I used that chip on. So basically what it does is it's just the way I figured it out and the way I made it. And then that's it. It goes up to here, and it works well. Looks like a charm. It took me a while, about a week or 2 to make it, and then here's the back side. Yeah, it took me a lot of thought to do that. And then when I try it, what I do is I plug it in. It's not working. It's because it's too light in here. And if I make it darker, there it is. I put LEDs on here too. One just turns it on. One connects to the 5 chip, which is the blue one. The green one is just on and off. And then when it gets dark, it counts. It sets back to 0. And when it gets light again, it turns off. I hope you guys enjoyed the video, and feel free to comment if you have any questions or comments, and comment below, and hope you enjoy it. Please like and subscribe. Thanks for watching.